Here we go. Paul's online notes, common graphs, transformations. Turning a base graph, like a quadratic, which is a U shape, which is a parabola, into some other similar looking graph in a sequence of finite steps. Let's go. Transformations. So the first function that I'm to transform is the square root of x plus 4. This will be the square root of x graph translated by 4 units. And I will show that. Let's just grab a piece of the x algebra. Let's decide how much of it we will grab exactly. Now, extendify it, make it occupy half the page, more or less. Anyway, now the standard square root graph passes through 0, 0, 0, 1, 1, 4, 2, and 9, 3, and so on. What about the transformed graph where I translated upwards by exactly 4 units? This point will come up here, and this point will come up here, and this one here. A nice, smooth half of a parabola opening up towards the right. And that's the first function done. Now, function number 2 is x cubed minus 2. The standard x cubed graph kind of vaguely looks like this, passing through the origin, of course, and this will be translated down by exactly 2 units. So let's go. All right, so I want to have as many points above the axis as below, sort of. Something a little bit like that. And let's see about getting to it. Okay. Oh, and I guess not. Guess there's not enough room. Now, they do say sketch the graph, so at some point I will stop plotting them. But for now, oh yes, I said I was going to figure out how to compress the y-axis, right? It's kind of a skill that I actually... all right, so what does the base function look like? Well, it passes through 0, 0, 1, 1, because 1 cubed is 1, and 2, 8. And then minus 1, minus 1, and minus 2, minus 8. So that's the base function. But the minus 2 translates everything downwards by 2 units. So this 0, 0 will now be down here. This 1, 1 will now be down here at 1, minus 1. And this 2, 8 will be at 2, 6. 2, 6. this negative 1 comma negative 1 will be negative 1 comma negative 3. And off the screen a little bit, about there-ish. Okay. So now we just connect it up. There you go. And, oh boy, that wasn't so good. Try again. Yeah, something like that. There. Graph 3. The absolute value of x plus 2. The absolute value of x plus 2. So just plain old the absolute value function, just the regular old absolute value function, kind of looks sort of like a v. Like a v with like that. That's the just plain old regular absolute value function. But I like to do my base functions in blue. And then my transformed function, well, for a function, if I do this, if I go inside where x is and I add 2 to it, that has the effect of shifting the function 2 units to the left, translating it rigidly 2 units to the left. And the way that I think about it, because I mean, it sounds like the opposite to what you would expect, right? I'm having to go -2, right? I don't think of it in terms of the function moving. I think of it in terms of the background moving. Good, isn't it? So anyway, what does that look like? So it'll look like there. Okay, and right, who's next? We'll check all these afterwards. Now, regular x squared looks like a U shape, or more fancy, a parabola on the origin, and which is opening upwards. There's the xy plane, and it basically looks like that. Okay. Here I'm going into where x is, and I'm subtracting 5 from x. So the appropriate thing to do is to the xy plane, and here's the base quadratic, passes through 0, 0, 1, 1, 2, 4, and 3, 9. And then it's symmetrical about the y-axis. But the transformed function will have its vertex at 5, 7, 4, 9. There, like that. Symmetrical point there, and there, and there, there. And then just so. Next, wait, did I call that? Yes, I did call that question 4, so that's all fine. For question 5, we have negative x cubed. That will be the regular x cubed graph, which climbs from the bottom left to the top right. It's an increasing function, and it has that sort of characteristic saddle shape, sort of. And this will be a reflection of that in the x-axis. So now it'll climb, now it'll descend from the top left down to the bottom right. So in sketching that, I really do want to figure out how to modify the axes. So GeoGebra compress axes. Let's figure this out. Hold on. Okay. Oh, I'm doing it. All right. More values. Okay. Now this is going to look a lot better, isn't it? Wonderful. So the base function passes through 1, 1, 2, 8, and 3, 27. Very steep. It grows very steep. And then -1, -1, -2, -8, and -3, -27. That's the base function. But this will be flipped. So let's do it. So origin still passes through the origin. Then 1, -1, 2, -8, and 3, -27. Just there like that. -1, 1, -2, 8, 27. Just there like that. That's pretty good for that part. And there you go. All right. For the next problem, we are applying two transformations to the base function. Generally speaking, it's sort of like we're doing this. Base function is the square root of x. So what do I do? The +4 will shift the square root function of x to the left by 4 units. And the -3 will shift it down, translate it down by 3 units. So instead of starting at 0, 0, it'll start at -4, -3. -4, -3. And so let's check it out. Now I will be thinking about symmetry. Determine the symmetry of each of the following equations. Okay, so how to do that? First, now how am I going to actually remember these tests for symmetry? Well, y equals x squared is symmetric about the y-axis. The way that you can test that is you can replace every single x that you see with negative x, and if you end up with the same function, then it's symmetrical. Okay, I get that. Whereas for being symmetric about the wait, did I say symmetric about the y-axis? I think I did. Yeah, that's fine. As well, for the other axis, I mean, it would be exactly the same principle. But then for symmetry about the origin, you would replace them both with negative signs. All right, okay, so we'll do this. We're going to have to check at each step along the way. Okay. So sub negative x, and we'll see what we get. We get negative x equals 4y to the 6. Like that. So not symmetric about y-axis. I think that's quite clear. And now sub negative y. Maybe I should also say sub negative x for x, sub negative y for y, like that. Yeah, that's pretty darn clear, right? So let's see, what do I get? I get x equals 4, open brackets, negative y. Just all right, so here I am. And yes, where was I? Right, so trying to defeat this by thinking alone. So first, let's input 0, and that will give us our y-intercept. And when we do that, we can clearly see that it's 6. Then set it equal to 0, and 6 minus 2x is equal to 0. So 2x is equal to 6. So x is equal to 3. Then finding the asymptotes. Okay, so it's undefined when x is equal to 1. All right, but that's what it looks like. Well, I don't know, but I have to try. Because just looking up rules and blindly applying them helps no one, and it doesn't help you. So the y-intercept is 6. And the x-intercept is 3. And it's you know what, I'm going to do it like this. There. So I think it looks like that. But now it's time to see. Nope. Completely, utterly wrong. Man. Oh my goodness me. How am I going to get over this error? I need to think about why does it actually look like this though. So Desmos is fine. Oh goodness me. Right, well I've got it's loading now. There, finally. Now right, just do this for now. I don't need the brackets there, but you know. Whereas if I at, oh, it's a straight line, but that, why is that the case? I mean, I could just input values and can't you see, but I need to like make an argument to myself that makes me realize like, of course it looks like this, but it's pretty darn difficult for me to think about that. How can I convince myself that this has to be the shape of it? What if I do this? Change this to like 3. That doesn't help me or convince me of anything. So why does it look like this? Hmm. Maybe. What does that? How to convince myself that this is correct? Well, think about it like this. When you have something that is incredibly close to -10 for x, then the origin just remains a good old whole number, but you're dividing it by something that's like vanishingly close to 0. So it will shoot off to infinity in that way. And then think of the other extreme, like think of inserting infinity somehow. I guess I'm sort of maybe starting to get it a little bit. I kind of feel it a little bit. All right, so round 2. While thinking this through. So the question is, I mean, that's wrong, what I've graphed there, so I may as well just get rid of it completely. The question is, what do these numbers 6, 3, and 1 mean? Okay, so they mean that there's some kind of asymptote there. That's the vertical asymptote. That's how I can think of it. But as for the horizontal, I think it would be 2. Would it be 2? Yeah, I think it would be 2. So we're gonna see, and we're gonna see if that's right. 2, and we'll call that 1. And what's it gonna look like? The reciprocal graph. It doesn't make any sense. There's no way that it can look like that, though. Okay, so it would have to look like this by the 6 and the 3. That would be 6, and that would be 3. See if that's correct now. Okay, that's correct. And now to think about the third one. So I think this. And what's the minimum of x squared at x takes 6? Well, the line of symmetry is that. Minus 6 1/4. So it would be 8 over minus 6 1/4. So like that. You put 1.9, you get 3.61. Then add 1.9 to that. You get 4.3.61 out of 1.9. Whoops. 5.51. 5.5126 is negative 0.09. Same thing for this. That's me getting really close to 2, and then if I get really close to negative 3 from the right, let's see, I get like, let's just say negative 2. Okay, square that, I get 4. 4 take 2 is 2, and then 2 take 6 is negative 4, and a divided by negative 4 is negative 2. So what is it's? I do think that it's actually doing this. All right. Well, what's it doing on the other side? Just think about it. Like, does it actually? Like, what y coordinates are never going to output? I could do that, but I don't want to do that. Look, can you divide 8 by anything and get 0? Yes or no? Well, no, of course you can't. So that means that it will never give you 0, right? Okay, so now just put in a value that's bigger than 2, like, I don't know, 3. So 3 squared at 3, that gives you 12. 12 takes 6 is 6. So here, it's doing what you think it's going to do. Your intuitions are right. You've got to reward my intuitions when they're getting it right. Okay, now, input negative 10. Okay, square that, I get 100, 100, take 10, take 6. It's still positive, positive and positive. So it's going to do this. I think. I don't know, but I think. So I'm going to be clear here. This is what I'm placing my bets on. The asymptotes vertically going to be -3 and 2, and horizontally x-axis. And as for the y-intercept, there's no x-intercept. As for the y-intercept, you stick in that, and that would be 8 over -6, which is -4 over 3. So I think that's correct. Which, no doubt, it's obvious to someone else, but I don't care. I can only learn at my rate. So now we have a quadratic divided by another quadratic, and I wonder what does this look like. Okay, so remarks. The denominator can be factorized into x take 4 times x at 2, and the numerator can be factorized as well. Oh, okay. So we have evenness to worry about as well. Right, that's pleasant. So 4 on the top. There. There. And now what? So it's undefined. At x equals 4 and -2. And now where does it cross the y-axis? Inputting 0, we get -36 over -8, which is 36 over 8, which is 18 over 4, which is 9 over 2. So there-ish, I say. And now to figure out what it actually looks like. We're going to do it. Okay, first. Oh, goodness me. Figuring out the asymptotes of this. What an absolute nightmare. Wait. We didn't figure out the x-intercepts. Right. 4x squared take 36 equals 0, so up there. So that would be +3 and -3. Yeah. That's cool. -3 and -3. There you go. Now, what I want to do now is I want to input things that are just a little bit above 4, something like that, right? Is that good? Look, just to input something insanely huge. Okay, so we get 4 times infinity over infinity. And so 4. Yeah, 4. It's going to be 4. Which is, I don't know what 4 is. It should be less than this one, right? Yeah, that's good. Not quite as underneath it as I wanted, but there you go. So 4. And now think about what it's doing at 5. So we get no, just input 10, 10. Input 10. So 400 take 36 is 374, and then on the bottom 72. So you just need to figure out if it's more than 4. Okay. 400 take 36, 374. Beg your pardon, 364 over 72. That's clearly more than 4. So I think it does this. That's what I think. I think it does that. I don't know, but I think. And if you input supermassive mega negative infinity, it outputs like still it's going to be positive with positive. So it will be positive at the I think it does this. That's me personally. Now, the middle, I don't know. I know it passes through there. But what do you think it does? All right. Goodness me. Okay. I'm going to guess that it does this and this. Do you really want to think that it does that? Do you really know? Fine. Just input -1. Just see. No, that doesn't work. That just does not work. You're gonna have to see. It's the only way. It's the only way. Here we go. If it looks totally like preposterously wrong, there it is. It's in view. It wasn't in view. Then I'm gonna be seriously so. I just had to. Okay, what a calculator is for. You know, test. In the future. All right. So I actually think, that's not bad. I think that's not horrendous. I got all the points right. It's just this sort of asymptote approaching behavior that I need to get under control. And the way I'm going to do that is with the calculator in the future, because they're not gonna look this pleasant, right? Okay. But other than that, I consider it okay. Should come back for round 2 at some point in the future. So who's next? Well, chapter 4 is finished. Hooray. What's coming up next is polynomials. And first is division. We need to learn long division and we need to learn synthetic division. And after that, who's after that? Okay, so this chapter 5 is going to be. It's gonna. It'll be good. Be well.